Good morning, good afternoon, good evening from wherever you are, everybody, and welcome to our webinar on optimizing your maintenance strategies and reducing process downtime, all with the help of digitalization and heartbeat technology for liquid analytical sensors. Bit of a mouthful. This is I think it's our 7th or 8th webinar we've run here in Australia, and those all being a mixture between product-related webinars, industry-related webinars, and this one is going to be across all industries, and we're lucky enough to have Oliver here, who you'll see on the other webcam. I'll let Oliver do an introduction in a second. Oliver, can you just go to the next slide, please? So for those of you who've not seen the GoToWebinar interface or not used GoToWebinar before, here's what you should see on your screen. So at the top, you should see a video of myself and Oliver, either on the left or on the right. On the right-hand side, you'll see the dashboard. On the dashboard, you'll check the audio at the top. Hopefully everybody can hear me. We haven't seen any issues yet. Below that, there's handouts. We'll actually be sending presentation slides at some point tomorrow instead. And then below that is questions. So we've got quite a bit to get through today. So rather than answer questions as they come, if you do have any questions, type them into that box, and we should have around 5-10 minutes at the end for myself and Oliver to answer those. So next slide, please, Oliver. So now just an introduction. So my name is Luke, and I'm the industry manager for water and wastewater here in Australia. I've been with Endress+Hauser for nearly exactly 3 years. It was 3 years on Monday. Before that, I worked in sales for water and wastewater in Queensland and Brisbane, which is where I live at the moment. And now I'll pass over to you, Oliver.
Okay, also good afternoon, ladies and gentlemen, from my side. Good afternoon, Asia Pacific, and also good morning, Europe. It's a pleasure for me to present to you today. My name is Oliver Durm. I am from the Liquid Analysis division at Endress+Hauser, based in Stuttgart, southern Germany. And as a product manager, I'm responsible for the Liquidline CM44 transmitter platform for the maintenance. And today, we will present you the advantages of digitalization and heartbeat technology in liquid analytical devices, because this is a real game changer.
Brilliant. Okay, that's all from me, everybody, for the next 30-35 minutes. And now I'm going to turn off my webcam and hand you over to Oliver. Oliver, all yours.
Okay, thank you, Luke. Okay, just some questions up front. Now you will see the slide. So on the right side, you see the CapEx and the OpEx, the life cycle cost of an installation within a plant. So at the beginning, it starts with the capital expenditures, investment cost, which is the engineering phase, the procurement, the installation, also the setup. This is needs around weeks or months. But as you see, the major part of life cycle cost is the OpEx, the operational expenditure, which can be up to 25 years. And what we will show you today with heartbeat technology, this directly affects your OpEx, how you can reduce your operational expenditures. So maybe just some questions up front. Do you want to reach the perfect balance between your maintenance efforts, but also to achieve still highest possible plant availability? Yes, I suppose. Do you want to reduce your documentation and verification efforts that you have to do? Maybe you have to do regulatory demands, requirements. Probably yes. And also, would you like to integrate all this information, all this data, these results, maybe electronically into your ERP, which is the enterprise resource planning system, to avoid classical paperwork? Well, then you are right today here. So the agenda of today will be, we will talk about the benefits of digitalization in liquid analysis. We will talk briefly about the portfolio, and then what is heartbeat technology in liquid analysis, what are the advantages and also the use cases of heartbeat technology, and then a brief summary. So on that slide, you see the topology of a classical measuring point. For example, if you also use analog sensors and analog transmitters. So how does it work? On the left side, you see your sensor. This can be a pH, conductivity, oxygen measurement, for example. And here you see you have very, very small physical signals like millivolt, nanoampere, or in the mega ohm range area if you talk about pH. And then you also need quite good quality cables to bring these very, very small, very tiny values to the transmitter. On the transmitter, you see you have mostly, if you use an analog system, different transmitters depending on the sensor you are using, because the transmitter, the input of the transmitter must match to the sensor. And then there is a cable, and then you communicate the measurement values to your PLC, which can be 4to20, hard, Profibus, Profinet, Ethernet, IP, whatever. What you see out of that is you need different sensors, you have different raw signals to measure, you also need different transmitters, different modules maybe because of different communication topologies. And that's a big variance for procurement, for logistics, but also for commissioning and also for maintenance. Think about calibration. And then also to integrate all these different systems into your PLC or your SCADA system. Let's do an example for a pH measurement, pH with a classical system, analog system, because pH is a high impedance measurement. What are the consequences to achieve acceptable accuracy and also reproducibility? It's mandatory to use high quality components and especially also a careful wiring. Why? When you measure liquids, you always have humidity, you have moisture, so you need golden electromagnetic contacts to avoid corrosion of the contacts. Also, you need watertight contacts, because also water will cause any little currents and will destroy the accuracy of your measurement. You need quality cables with a long-term stable isolation material. Why? Because if you have sunshine, if you have all the environment, the isolation material, the PE or what is inside, this will change by time. And if the resistance or the impedance of the cable is changing over time, this will also affect your measurement accuracy and also your reproducibility. The shorter the cable, the better. And you also have to take care on EMI interferences, ground loops, galvanic isolation. Well, what's that? Maybe some of you will experience this when you want to connect your PC to your audio hi-fi system at home, and then sometimes you hear a hum. Or when you are on a concert, maybe at the beginning when they are testing, you hear this hum via the loudspeaker. So this is a ground loop, and this needs to be fixed. And imagine you have such a ground loop on your measurement signal, such a hum. This will also have a consequence on the accuracy and also the reproducibility. At the end of the day, the calibration of the loop must be done in the field directly at the measuring point. If it's raining, if it's hot, if it's cold, it must be done there because the cable, the connectors, everything plays a role. So what does it mean for a sensor calibration with such a classical system? When there is maintenance needed because there is maybe an error or you have a cyclic working procedure, an SOP, what you do is you take the cleaning buffer, take the cleaning agent, take maybe a new sensor from the shelf, go to the measuring point, you remove the sensor, you clean the sensor or maybe exchange the sensor, and then you do the calibration with the buffer solutions, and after that you release the measuring point. As you can see, during this time you have a downtime. So it's time consuming because each loop needs an individual calibration. You have downtime during this process, and you need qualified maintenance personnel to do a correct calibration because temperature, outside ambient temperature, everything plays a role. That's the reason why we invented MemoSense sensors. MemoSense sensors is reducing the maintenance and is also making your measurement value more reliable because we convert any sensor in a digital and intelligent sensor. So what you can see here, you can even submerge it completely underwater. The contacts are watertight, no problem at all. On the next slide, you will get some more details on that. So a digital sensor based on MemoSense has inductive coupling, as you can see on the right. So the data and also the energy transfer is done via this inductive coupling. And this works the same way as you have it maybe if you have a toothbrush at home, electrical toothbrush, you put it on the charger. So that's the same principle. Or if you have a very modern mobile phone and you have these QI chargers, you put it on a charging plate and then that's it. So you have no contacts anymore. This means you have no contact corrosion at all, no interferences of the measured value. You even have a galvanic isolation, so you avoid also EMC troubles. So these headaches that you have from at classical systems in the past, you can really skip and can get away of that. So MemoSense technology is digitizing also the measurement value and stores the data in the sensor head. So what you can do now is you can pre-calibrate the sensor, and you can do a fast exchange of the pre-calibrated sensor at your measuring point. And then you can do the calibration under best conditions in the lab instead of the calibration in the field. You can also get alarm signals because we get information out of these digital signals. So you get more information to your transmitter. At the end of the day, MemoSense collects sensor and process data, for example, the sensor ID, the order code, raw values, extreme values, operating hours, adjustment or calibration values, also last time of calibration is inside. And all these data, this is the basis for heartbeat technology. Now, a digital MemoSense sensor, how does this procedure works now? You can do all the cleaning, the regeneration, the calibration, and also the documentation you can do in the lab under stable conditions. And then somebody can take the pre-calibrated sensor and can go to the measuring site, and he just needs to exchange the sensor. And this can be done by anybody. So this can happen also in the weekend. Just somebody, if something happens, can go to the shelf, take a pre-calibrated sensor, go to the measuring point and exchange the sensor, and that's all. Now, if we look on this maintenance and calibration procedure of digital sensors, so if there is a maintenance needed because there is maybe an error or there is a cyclic working procedure, you just take the pre-calibrated sensor, go to the measuring point, remove the old sensor, install the new pre-calibrated sensor, and release the measuring point. So the advantages, as you can see, are very obvious. Very short time is needed. So the lab calibration first can be done under stable conditions. You get a very accurate calibration. You have a quick sensor exchange. You can use pre-calibrated sensors. It's hot plug and play. You can change the sensors during operation. You minimize the downtime of your that you see measurement values of your process. So that's also quite cool. And also what you can do is now, for example, when you look on the data of the calibration in the lab, when you document this, you can also do some predictive or condition-oriented maintenance. And also you can document the life cycle of your sensor, which is often or very important in life science industries. So now, how does a topology of a digital measuring loop with MemoSense is looking like? You have the raw signals. You see on the left side the sensors. Directly inside of the sensors, the signals are converted to digital with this MemoSense head, and then you have your cable. It's just a standard cable where you transfer 1010. It's a digital signal, and then you have one transmitter. So what you can see now is you can do standardization. You have one cable that fits for all sensors. Hot plug and play of the sensors is reducing also your downtimes, and the transmitters, they are multi-channel, multi-parameter. So what does it mean? It's like, you can imagine like on your laptop, when you connect a mouse or when you connect a USB stick, a memory device, the laptop automatically recognizes which device you added. And it's the same now here with the transmitters. The transmitter automatically recognizes which sensor is connected, and then that's it. Then you can see the measurement value. So now you have multi-parameter transmitters. Multi-channel means you can do it with one there are transmitters with up to 8 channels. So this is also saving space because now in one transmitter, you can get up to 8 measuring loops inside. And then also now the operation concept is harmonized. So it's getting more easier for the people. You get a higher operational safety because everything is working in the same way. And you can use these pre-calibrated sensors. So this makes your maintenance much faster and also much more safe. And now, as you can imagine, in liquid analysis, there are a lot of different parameters to measure, from pH over P, conductivity, dissolved oxygen, chlorine, turbidity, etc. And how to manage all these different sensors. What we did is we developed one platform, which is the Liquiline CM44 platform. So you see at the top, this is the transmitter as a field housing device for outside installation, a cabinet device, which can be installed into a DIN rail on a cabinet for space saving. And then also we have wet chemical analyzers, water samplers, and to all these devices, you can connect these MemoSense sensors that talk MemoSense language, and where you have all these advantages with heartbeat technology. And now, what is heartbeat technology? So this was now the starter. Now you understood which information or what is the basis to realize heartbeat technology and liquid analysis. And now we start. So heartbeat technology at a glance. Heartbeat consists out of 3 modules, 3 pillars. One is the diagnostic module, which is permanent process and device diagnostics, 24 hours, 7 days a week. Second one is verification, which is documentation without process interruption. And the third one is monitoring, to bring all the information to your PLC or to your SCADA system. And this is information for predictive maintenance. At the end of the day, this is increasing your plant availability, makes your process more safe, is reducing verification efforts, and you can optimize your maintenance procedures. Now, what is heartbeat diagnosis in liquid analysis? These are 24 hours, 7 days a week, extensive self-diagnostics with clear icons for a first remedial action. And what we do is, you will get this as a condensed view. So we provide with heartbeat diagnostics an easy to understand visualization with smiley face. And this smiley face is understandable by everybody. And this also, with some clear text information, helps you to understand the diagnostic message immediately and avoids misinterpretations. Of course, a digital MemoSense sensor is a precondition, because only with digital MemoSense sensors you can get all this information. And now looking on the sensor, on the factors, so what is causing stress to a sensor or causing defects or wear out or aging. So if you have a sensor, for example, operating in very extreme conditions like very low pH values, very high pH values, what you have, for example, in the mining industry and leaching, or when you have operating hours, the sensor is exposed to extreme temperatures above 80, above 120 degrees. This you often have, for example, in food industry or in SIP, where you have or cleaning in place industry, in industries where you use cleaning in place, where you clean the sensor with acids or with alkaline solutions, and also use high temperature to get it sterilized. Life science industry, for example. Then also, for example, in a wastewater plant, you have optical sensors with a flash lamp. So we have also lamp operating hours. We calculate the flash lamp counter, the filters, the optical filters, for example, in an aeration base, when you have a nitrate or a sensor like that, or a turbidity sensor. Also, we look on the lamp intensity on these optical sensors in a turbidity measurement, for example. Membrane calibration, electrolyte counter. If you use disinfection in a drinking water plant, where you use disinfection or chlorine, for example, we have electrolyte counter inside, or oxygen. If you have oxygen sensors and parametric oxygen sensors, there is an electrolyte counter inside. Minimum, maximum measured temperature is taken into calculation. And then, as mentioned, sterilization in place, cleaning in place, which is in food and beverage industry, leakage current, sensor power supply, much more. So these are just some examples which, if you expose the sensor to extreme conditions, this is causing stress, and of course also is aging the sensor. Now, what we do is we take all this information, all this diagnostic information, and provide a clear status, this smiley icon. So this smiley icon, why did we choose that? Because this is understandable worldwide. In every cultures, everybody knows a smiley icon. Smiley is okay. When it's going to sad, I need to do something. So this is a visualization everybody can understand. And now, what are the factors that influence this heartbeat status? So first, we look on we monitor internal sensor values. Second, we look on calibration results. And third, we also look on the sensor history. Out of that, we calculate a so-called health, a sensor health, which is a value from 100% going down to 0%. And together with the maintenance timer is a timer that you can preset according your SOP, according your standard operating procedures. Some do the maintenance every 14 days, others do it every 30 days. So this depends on you. You set up the timer. And together, these both together, with this, we calculate the heartbeat status. So if they fall below a certain percentage level, then the smiley icon changes from smiling to neutral or to sad. Let's do an example now. For example, with pH. On the left side, you see these advanced self-tests during operation, during calibration, and also these time-based, these historic events which are recorded. So for example, at pH, we also look on we have self-monitoring on the hardware itself, on the electronics, but also we look on the connection check to the transmitter, on the sensor power supply, the glass impedance, or if you have a parametric sensor, we look also on the electrolyte counter or the optical lamps. Then during calibration, we look on the slope evaluation, the difference between the slope adjustments, 0-point evaluation, etc. and also these time-based events like operating hours, exposing to very extreme conditions which are stressing the sensors, extreme pH values, for example, or extreme temperatures, SIP or CIP counter, etc. And out of that, we calculate the so-called health. You see, starting at good, which is 100%, going down to you need to check it. And then also the maintenance timer. So here in this example, the customer said, my SOP is every 14 days, I look at the measuring point, I do a maintenance. So now 6 days of these 14 days are left. And out of this, the icon, the smiley icon is calculated. And I think now on the next slide, we will have a poll. Yes. So Luc, do you want to take over?
I will, yes. Hello, everybody. I'm just interrupting Oliver's great presentation again. But yeah, based upon the previous slides that Oliver explained regarding maintenance timers and sensor health, we've got a poll that we'd like to run. And the question is, if the maintenance timer had reached 0 days, yet the sensor health was still good, what would be the best course of action for maintenance optimization? So I'm just going to launch the poll now, and you'll be able to click on the answer. So the 3 options we've given you are do nothing, do maintenance, or increase time between maintenance. So I'll just give you all around 20 seconds to answer that. Should, looking good. Got nearly half the audience voting. Perfect. Okay, I'm going to close that, and then I'm just going to show everybody the answers, which are right there. Brilliant. So we've got a bit of a mix of answers there. Oliver, hang on, let me just share that one more time. Okay. So the answers are, okay, so we've got most of the people saying increased time between maintenance. So would you like to follow that up, Oliver?
Perfect. Yeah, that's the correct answer, to increase the maintenance, because if you see on the measuring or on the screen, maintenance timer has elapsed, but the sensor health is still okay, then a conclusion could be I can change the interval, for example, from 14 days to 28 days. And what does it mean? Now you can save maintenance cost, because you see you don't have to do the maintenance that often. So that's an example.
Brilliant. So really simple example of how you can extend your maintenance intervals and optimize your maintenance there. So Oliver, I'm going to hand back over to you.
Okay. On the other hand, also, if the maintenance timer is still okay, it's still 20 days left, for example, but the sensor health means check, then you know, oh, maybe this measuring point I have to maintain more often, because yeah, the sensor is aging in my process much more. So that's also to increase the availability. You get helpful information. So how does it look like? So on the Liquiline devices, you have a main measurement screen. On this main screen, you see all the channels with the connected sensors. So now we have a 4-channel device with 4 connected sensors. And then you see the smiley icon, so you directly see the status of the pH sensor, conductivity, oxygen, and nitrate in that case. As soon as heartbeat is activated, you will get on the first line, you will get this heartbeat diagnostic, what you see here now on the left side, black underlined. If you press on that, you will get a more detailed screen, which shows you more in detail your sensor health and also the maintenance time. If the icon changes from smiley to neutral or to sad, you will get a help button here on the bottom. And this help button will give you more information. What is the cause that the sensor health maybe is going down? If there is a failure, you will also get a clear text message. So it's not only a number, an error code, it's also a clear message with a remedy action, what you can do so that everybody understands immediately what has to be done. Now, as you can imagine, depending on the sensor and the parameters, I don't want to go in detail now on that slide. It depends on the sensor type, if it's a pH, optical DO, and parametric DO, or if it's a disinfection sensor, conductivity, photometers, nitrate. It depends, sorry, which sensor you are using. There are different factors which are taken into calculation for this health calculation. Of course, also the transmitter, the Liquiline device itself, we have a health calculation. Now let's take the example for a water station, for a water sampler. There are several pumps inside, tubes, sealings, dosing valves, and also we look on the internal electronics. And if the counters reach a user-defined limit, you can also set a user, you can set define a value. Then if the self-monitoring detects that some counter is exceeded, then you will also get a change in the health icon. And now we have something inside of the liquid line devices which we call a dashboard with key performance indicators. Why did we do that? The reason was a very big customer in the petrochemical industry at the time came to us and said, it was from the maintenance, I need to reduce my maintenance cost. My boss told me I need to reduce my maintenance costs, but I have also the target to keep the availability of the loop as high as it must be always 100%. How can I balance that? Can you provide us some KPIs that we can make that more easy? And that's the reason why we developed this KPI screen. First, it was done with the CM42, with the DTMs, but now we also directly took this over for the CM44 liquid line platform. And now how does it look like? So we have a KPI dashboard where you see the availability, the operating time, the time in failure, the number of failures per sensor and also per device that occurred. And then what we also do have is a so-called MTBF, a mean time between failures in operation, a mean time to repair in operation. We also know the time, how long the liquid line and the sensor was in calibration mode, number of calibrations, and also the mean time between calibrations. What you can see right now here is these are real calculated values. So the MTBF, when I was at university, I learned MTBF is a statistical average value, but what does this average value mean? Often these are very large numbers, 100 years, 1000 years. So normally only you say, okay, the higher the number, the better. But what does it really mean? So these here are real experienced records. And as you see, we calculate this out of the different factors. So you get a KPI about, for example, can I improve the mean time between failures? Can I change or can I improve the mean time to repair or the mean time between calibrations? So this tells you directly, gives you information. If you change something in your maintenance procedures, and directly you will see the effects in these KPIs. And I will give you now on the next slide some examples how you can use that. Here, for example, this is a picture. You have a wastewater plant, wastewater treatment plant, inlet. In the inlet, you have flowing a lot of things. Now you see here, oh, my availability is low on the headline. So out of that, you directly see, oh, maybe I have to increase, the maintenance interval is too long. So maybe a shorter maintenance interval will improve the availability. Now let's take an example, for example, in food and beverage, inline pH measurement with the MTBF. For example, if the MTBF is low, maybe the sensor breaks more often. What you first get is, oh, maybe I need to install a protection cage around the sensor, or I try another sensor, maybe an ISFET sensor. This example could also work, for example, in wastewater plant. If you have an inlet and the sensor breaks very often. Why? Because maybe some wood is coming along the inlet river and is destroying the sensor. You can install a protection cage or try another sensor like a CPF81D, for example. Then mean time to repair, an example for the mining industry. So for example, a DO measurement or a pH measurement in the leaching process. If the mean time to repair is high, what does it mean? It needs a long time until your device was repaired when there was a failure. So what could be the issue? Maybe one issue could be that the maintenance people did not get the information right in time, that it needed a long time, that they got the information that they have to do something. Maybe there was a lack of resources to maintain this measuring point, or maybe the reason that it was a long time, it needed a long time to repair is there were no spare parts on stock. Just some simple issue. So out of these KPIs, you see, what can I do in my procedures, in my process, that I can improve these numbers. So you get ideas, you get information out of that. And so this is this reason why we developed now together with this customer, these KPIs, MTDR, MTBF, etc., that you get easier the informations to find something. This is something which fits to all industries. MTBC, mean time between calibration. The device, the liquid line device, knows how long it is in the calibration mode when you do a local calibration. And okay, to reduce this mean time between calibrations, to make that interval shorter, a perfect example would be, for example, to do a lab calibration with the sensor, for example, with MemoBase Plus, and then you just do a fast exchange of the sensor in the field. This means then you reduce the time the device is in calibration, and therefore you can reduce this KPI. Now, next pillar, next module of Heartbeat is heartbeat verification. Heartbeat verification ensures the reliability of your complete loop with a documented report. So this is minimizing your documentation efforts to fulfill regulatory requirements. In life science, this is called GMP, good manufacturing practice. So What is it? On the liquid line screen, what you have is you have a one click, and by clicking there, the liquid line is doing the verification. The report that you will get is a PDF file. So this PDF you can get from the device either via the SD card, but you can also remotely download this file via the integrated web server. That's also possible. So if you're far away, no problem, press the verification button, then you can download the file. You will get an overview of passed and failed on the title page. You see also the tag name, the product family, installation location. You get the current order code, firmware version, etc. You can put a signature line on that. You can print out this report, put your signature and a stamp on it, and then you can file it. So you have it always. If there are some reviews, some audits, you can show, look, I did the last calibration, the last maintenance on that time. Depending, okay, here on the second screen, on the second page of the report, you will get more details about the liquid line itself, about the modules that are installed, also these heartbeat KPIs. And what is also available inside is you get detailed verification reports on the CPU, but also on the 420 milliamp out if you have 420. So what is the advantage? What we can do with the liquid line is to make some kind of loop check. So we can read back the 420 milliamp value. And what is the use case? For example, at the first commissioning, you do all the installation, you do the wiring, you connect the device to your PLC, to the input modules, the 420 milliamp inputs on your PLC. And now when you press the verification button, the liquid line will check, is the connection to my PLC, is this working? Because we can read back the current through the PLC. So you can check the cabling, you can check also the connection of the wires. So after commissioning, you can make this report and you say, look here, everything is working fine, it's documented, it's running. And depending on the amount of sensors, you get also a separate page per sensor for each sensor with information about the connected sensor, serial number, order code, when it was calibrated last time, sensor health, and all these KPIs I mentioned before. Okay, this is now in detail, which we explained already. So we can go on that one. This was the verification results on the second page, the loop check, what we can do. And also here are these KPIs. You will get all the slides, by the way, so you can also look later on in detail on that. And now the last pillar of heartbeat technology is heartbeat monitoring. What is heartbeat monitoring? I showed you all this information, what we get through MemoSense, the last calibration date, the operating hour counters, the, for example, on the disinfection sensors, the electrolyte counter. All this information you can transmit to your PLC, including all these KPIs like MTBF, availability, heartbeat, and so on, the status, you can transmit to your PLC. And when you monitor this on your PLC, you can identify potential issues with your application, or you get trends in your process over a period of time. What we recommend is that you use a digital field bus, because via 420 milliamp, you will know you can only transmit one value via 420 milliamp cable. And so it's not very efficient. It's more efficient if you use digital field bus, then you have a single cable and you can get all this variety of measurements directly to the PLC. Of course, if you're only using 420 milliamp, a few KPIs you can transmit also. So what is the difference between heartbeat diagnostic and heartbeat monitoring? It's quite easy. Diagnostic is the status at a given time point. The monitoring, when you broadcast all these values, when you transmit all these values to your PLC and record them over time, you will get a change, and this is then over time. This is the monitoring functionality. I will show it to you on the next slide as an example. So here, for example, on the PLC, we are logging the heartbeat status, the same as you monitor the pH value or the temperature. We are logging now the heartbeat status, or the disinfection sensor, for example, the amperometric, the electrolyte counter. So now we are looking on that. And now, normally you would say, okay, I see the line is going like that, the slope is like that. So I would extrapolate the maintenance time. The next maintenance I will need to do is, you see on the right side, very on the right side. But now, when you do the monitoring on your PLC, remotely already you see, oh, my heartbeat status has changed. And now you can look with the magnifying glass, it's indicated here, you can look in detail, what has happened here? Maybe did I change something in the process? What happened which caused stress to the sensor? Maybe it was a maintenance procedure I did in a perfect way, so that was the reason why the sensors aged. can be anything. But now you get a detail and information. It happened something here. Can I do something to increase the maintenance cycle? Also now, when you look on this graph, you get also then the trend, and then you see, oh, maybe the recommended maintenance is earlier than I would normally expect. So this prevents you for sudden failures, because you can do some, let's say, like some condition-oriented maintenance already in that way, like a predictive maintenance. Now, to bring all this information to your SCADA system, to your PLC, you need communication. So with the Liquidline platform, we support different communications, like the classical 420 milliamp communication, hard communication, hard 7. We also have RS485 based communication like Profibus DP, Modbus RTU, and also Ethernet based communication, where we see right now a big trend with Modbus TCP, Ethernet IP, Profinet, and the web server. And what we introduced now recently, beginning of this year, was an evolution in the Liquidline platform that all Liquidline devices that are ordered from now on will have an Ethernet connector on board. So this makes it much more easier if you are still using 420, but to get a step into Ethernet-based communication in parallel, or using the web server, making it more comfortable for you. So, as a summary, Heartbeat in liquid analysis. Heartbeat technology provides you a lot of helpful information about the measuring point for minimizing and also your maintenance and operation expenditures. So Heartbeat Diagnostics is a continuous 24 hours, 7 days a week self-diagnostics with KPIs, with a very easy to understand visualization with this smiley face. And this is increasing your measuring loop. And this also takes out the guesswork of your maintenance procedures and helps you to manage your maintenance resources more efficiently. With Heartbeat verification, this is documenting the entire loop with reports and is minimizing your documentation effort. It's just a single press and then you get this PDF report. And with Heartbeat monitoring, this is to bring all this information to your PLC, remotely available. And by monitoring all the KPIs over time, you can identify trends. And this is the way how it can help. Also, for example, you can get a big overview on your plant when you have different measuring points. When you look on the last calibration date, you directly see, I have calibrated this sensor or this measuring loop last time on that date, this one there. So this is very nice. This is also a step towards IoT. All right, so now I hand over to Luc, the microphone. This was the last slide on the presentation.
Brilliant, thank you, Oliver. That was brilliant. Thanks very much for your presentation. As you can see, everybody, there is so much information you can bring back from these sensors. With Heartbeat Diagnostics, verification and monitoring, there's a lot of opportunity for you to really enhance your maintenance procedures. So thank you so much, Oliver, because you've made quite a complicated subject very simple for me to understand, and it's simple for me. I'm sure it's good for the audience as well. So we do have some questions. We do have a little bit of time left to answer some of those. Straight at the start, we had a question from Rodney, Oliver, and we also had a very similar question from Brad, and it was about how to bring back some of that data. So those KPIs, those diagnostics, how to bring back that data over HART firstly, and then maybe over digital comms. So can you answer that question?
Did I got it right? How to bring this information via HART? I didn't got it right. Can you
exactly? Yes. Yeah. So how to bring back the KPIs, the smiley face data, MTBF, all of that data back over your SCADA system.
That's a good question. So if you go, for example, you need information how to get access on these data. So on our website, if you go to the product website of the Liquidline, for example, if you type into the search field CM444, then you will get the product website. And then there is a section which says documentation, manuals, software. And if you go to this section, you will find documentation which is called special documentation, SD. And if you click on that, it will open a window, or it will open a chapter where you can get all these guidelines, how to access the data via HART, how to get access to data via Profinet, via Profibus, via Modbus, via Ethernet IP. There are separate documents which document for each digital field bus how to access this data. So the programmer will know which register or how to get these things via AOP file, can I access them and integrate them into my PLC.
Brilliant. So all that information is available online, and when we send the email out tomorrow at some point, we'll provide a link to that, Rodney and Brad. We had a question regarding the KPIs. So the KPIs for heartbeat diagnostics, I think, are quite unique to liquid analysis. Rodney had a question whether these KPIs were available with any other E&H products.
Well, this is right now in discussion, so this could be also available in the other ones quite soon. So we started with that because of a customer inquiry. We directly implemented that, and as you see, it's quite helpful. This could also pour into other products, of course.
Yeah. Okay. Yeah. I mean, it's such a simple indication of the health of your sensor. So yeah, we'd like to see it on other products, I think, Rodney. We had a question regarding shelf life of pre-calibrated sensors from Phil. I think I know the answer to this one, Oliver. This is probably regarding pH probes. We say the pH probes have a minimum shelf life of around 1.5 years. If you calibrate them and leave them on the shelf, we would recommend they're calibrated probably every 6 months or so. So if you are ready to put it in your process, do a check on your transmitter to make sure that you've calibrated within 6 months. If you have, put it in the process. If not, do a quick calibration and you'll be good to go. Another question here, Oliver, I think we discussed this yesterday. So are there any plans to add Bluetooth to the transmitter to enable the download of these reports?
Oh, yes. We discussed yesterday about a slide. So we have a slide that shows the evolution of the Liquidline platform, and we started with CM44 platform 2010 already. We continuously invest into the platform. We maintain the platform to enhance it to modern things. So we started with 2-channel device up to 4, 8-channel, and now the next step is to integrate Bluetooth. Yes, that's definitely on the roadmap. Already working on that you can use your smartphone with SmartBlue, the app SmartBlue, where you can use all E&H devices, and then the Bluetooth will be also inside of the Liquidline CM44. Yeah.
Brilliant. Phil, there is actually an alternative to that. So with the new base module of the Liquidline transmitters, we've got an enhanced web server on that. So if you did want to download the report remotely, you still can just go straight in via the web server instead. And hopefully next year, maybe we'll see Bluetooth on it as well.
Yeah.
Another question. Okay, is heartbeat a default feature with all MemoSense-based analyzers or optional?
It's a very good question. Thanks for that question. Well, as you know, we have MemoSense sensors. We have all this information. So also today, if you have already an installed base, Liquidline MemoSense sensors installed 2015, 14, since many years ago, this information inside is available. To get use with heartbeat technology, what you just need is to upgrade to the latest firmware. So we support heartbeat starting from the Liquidline firmware 10604, but we recommend always to go to the latest one. You can also download it from the website. It's now 107. And then when you have upgraded your Liquidline device to the latest firmware, you just need only an activation code. An activation code that is depending on the serial number of your Liquidline device. So you have to provide a serial number, you can get an activation code. And then with this activation code, the heartbeat functionality in the software and the firmware of the Liquidline is activated. And then we do the calculation. We provide you this added value information with the smiley faces, the monitoring function then will be activated. That if you have a field bus, you can also get this information via the field bus, and also the verification reports are then available. So it's just an activation code. You don't need any hardware. So this is very easy to upgrade, very easy to do if you have an installed base.
Perfect. I think we've probably got time for one more question, Oliver. I think it's quite an easy one for you. So is free chlorine available with these heartbeat diagnostics functions?
Yes, also our chlorine, our disinfection. So we call it now disinfection portfolio because it's not only chlorine. We also have other disinfection sensors now in the portfolio, and also these sensors are supported. That's also available. You will, by the way, we are right now, it will be available in the very short terms, in the next couple of weeks. There will be a public heartbeat guidebook available, where you can read all that what I told you right now. You can read in detail again and read in calm. You will also get the reports, and there is also shown which sensors are supported. So it's all our MemoSense sensors, by the way, and also you will get a more detailed view on which sensors, which factors we take. So also this table, which I showed briefly, you will also find in this document, and this will be available for everybody then.
Brilliant. We are just run out of time. Yes, as what Oliver had mentioned, there's so many of these diagnostics we can pull out of this sensors, and this guidebook that should be coming out in the next 2 weeks. I've seen
Yeah.
our version of it and the external version. I've seen parts of it. It looks brilliant.
Yeah.
I think it's going to answer most of your questions that you may have. So that's it for us. Oliver, just want to thank you again for joining us.
Was a pleasure for me. Wish you a great evening, and yeah, to Europe, also a very great day today. Okay.
Brilliant. All right. Thanks,
See
everybody.
you.
Have a good day.
Bye bye.
See
Bye
ya.
bye.
Bye.